Welcome to our session on R, or Raster Bridge for Big Data, what is new in the R-ArcGIS Bridge. We don't really have a beginner session this year aside from the seminar this afternoon, so we'll be going over the basics up front, and then we're going to be extending that on to see what's sort of possible on the cloud and the big data sort of horizon. So it's really important to take note of this. If you got a phone, you may want to snap it. There's a lot of good information here. All the presentations are stored. And so if you miss something, you want to get back to it, of course, hang on to this address and go ahead and visit at your leisure. So we're starting with the introduction to the R bridge. So why R? Well, there's a lot of good reasons. How many people have been using R for a while? Just a couple, and so we have a lot of people new to R. Okay, so R is a statistical package. It's the most popular statistical language out there, and it's still the fastest growing statistical language out there. So it really has the lion market share of analysis, and that's not just in academia, it's also in different businesses and also in government. So it's great because it has a set of powerful core data structures that are very easy to use and very easy to see. So when you print the information, it's nice and clear. And those data structures are also used throughout all the little packages that are in R. So there's a lot of different core data structures that you can use, and as we'll see, they have spatial information. But probably more importantly is when I started this 13 years ago, I had about 30 people at the UC doing Python to call out to R stuff. And as the years went on, it got more popular and more popular. At the time, there were over 6,000 CRAN packages. And these CRAN packages are add-on packages. They come beyond the core. And they're written by people that do, let's say, your PhD project, and you do some core analytics, and it makes a breakthrough. And so you put your source code up on CRAN, and then people can use it. And so CRAN has grown over those 10 years from 6,000 to 12,000. So you can even find some really obscure packages like the spatial analytics of panda distributions or something like that. And then as well as other libraries that have a really, wide breadth of analytics. It is up to you to assure quality control. So while there are 12,000 CRAN packages, I will say that not all of them are great. And so really make sure that you look at who wrote the code, whether they're cited in journals, what their references are. Some of them have been around for a long time. Some are written by fantastic programmers, so you don't have to worry them. Some of them are even written with a lot of the source code in C, so that they're actually very efficient. Because R, as a whole, the R code is a little bit slower than some other languages, but when you write it in C, it isn't. And so it also has a very versatile plotting functions. So it's really easy to plot your information. Box plots and scatter plots and what have you is very easy. And you can make them look quite nice. There's also hooks into HTML, so you can have your stuff sent out on the cloud for nice visualizations. So it's really a well-rounded language, but more importantly, not only is the core powerful, but there's a ton of additional packages that make it very well-rounded. And if you have some analytic that you need to get done, and perhaps you don't know how to program it, or perhaps you don't want to reinvent the wheel, the chances are there probably is someone who's already done it, and you should really investigate, because maybe you can just import the library or add the package, install the package, import the library and use their code, and you're done, as opposed to trying to write all the code yourself. So some of the R objects I was talking about, the most important one is the Dataframe. The Dataframe, if you've used, let's say, Python and Pandas, Pandas Dataframe really came from the R Dataframe. And essentially, they're labeled columns or labeled variables. So you can ask for the Dataframe, and I want field growth or field population, and it gives you the information. And it's tabulated in a very nice fashion, so you can see your data quite easily. So also, on top of that, our objects, there are a ton of spatial objects. And this is important as we're in the GIS world. You've got to be able to take your shape information, actually use it in R. And so there are different packages that deal with points, lines, polygons, grids, rasters, that sort of stuff. So there is support for all the GIS types of shapes. So the R-ArcGIS bridge, why is it important? So it allows analysts to tap into field-specific statistics while still integrating it in your GIS, right? So primarily the R-Bridge is a data I/O operator, right? It gives us core native data access to our C++ cursors that then transform the data into the R objects that you need to do analytics. And we also have converters to go to the different specific spatial packages that you need for some of the other packages, right? For example, SP or SF or raster. So essentially, there's a lot of reasons why you'd want to use the R-Bridge, but primarily it is a data I/O. It is not a replacement for Python. You can't drive GP from it, but you can use it as a script tool. So you can use R as like a Python script tool. You can have an R script tool. So that's very nice. There's a look at the vignette. If you want to look at that, that's an intro vignette. And it'll walk you through the entire process of getting it set up and what it actually is about. We had Margine working for us. She just left, unfortunately, but she did a fantastic job with the vignettes. They're very well-rounded and very pertinent. Okay, so what are the requirements for the R-ArcGIS bridge? You need Pro 1.1 or later, R 3.2.2 or later. An ArcMap, you need 10.3.1 or later. And then RStudio is optional. I use RStudio a lot. You can use whatever you use for R. But if you're programming within the R environment, then you're going to have some sort of IDE, and I like RStudio. There are others. But generally speaking, the workflow is get your code working in an IDE without the GIS, using ArcGIS binding to read and write the data, do some conversions, do some projections on the fly, do some selections, whatever you want to do. And then once you get your workflow working, then you could wrap it into a script tool so that the GUI actually drives the R code, right? So how do we install the R-ArcGIS bridge in Pro? It's quite simple. You go to the project pane, click options, go to geoprocessing. There'll be a little indication for R. It'll auto-detect the version of R or versions of R that you have on your machine, and then you can click which one that you want to install, and it'll install for you. Okay, so it's quite easy in Pro. And then you can set the workspace in RStudio. And essentially you need to library the package, and then you need to check the products. You got to make sure you have a license on your machine. So that's how you get it set up when you're working in your IDE. So once it's installed, you should be able to use your IDE. Okay, using the R-Bridge. So you open ArcGIS, you have data, tables, layers. Let's work with vector data first. Here's an example. When you use the arc_open command, that's essentially like Python's describe, right? It sets up a pointer to what you're going to do, but it hasn't really read anything except for the describe information. It's going to give you properties of the feature class that you're interested in, the fields, the spatial reference, things like that. But you actually haven't read any of the data or the columns or the rows into R yet. When you want to do that, when you inspect it and you say, hey, I want fields X, Y, Z, then you say, I want to select the data. So this is arc.select. You give it the describe or the thing from the arc.open. You give it the fields that you want. You can give it SQL queries. And most importantly, you can project on the fly. So if you always want to do something in a spatial reference, or you want all of your data that are in different spatial references to all be projected to the same spatial reference, then the ArcGIS binding package will do that for you. That's a very nice convenience. Am I moving too fast? Is this good, the pace? Great. Okay, I'm going to go ahead and get started with a demo here. So let's pop out and look at vector data. And this is my RStudio. I'm going to do the analytics, not terribly important here, but what I'm going to do is an advanced spatial econometric model. So I'm going to do a regression model, and I'm going to actually use an advanced spatial econometric model to try and improve my regression. But more importantly, we need to note just how easy it is to get the data and just how easy it is to get the data out. So I essentially want to run these regressions, find the right regression. I want to create a new feature class with the same fields I used in the analysis, but I also want to append a residual field, the residuals for my regression. So I'm going to go ahead and library the information, source the libraries I need, check the product, and I have some information here, not just the shapefile of California polygons. There's 58 polygons. But I also have a GAL file, and the GAL file is like a spatial weights matrix, like a contiguity matrix. It just says for each ID who are my neighbors, and you need that for some spatial operations. So here I am. I'm going to go ahead and open the feature class, and here's my describe. So if I click here and I type info, we can see that info has all the fields. I have tons of fields. It has my projection, my WKT string. It has the geometry type. So that's the kind of information that comes, but we haven't read any of the data in. So I'm going to go ahead and select out of that the unique ID field. I want growth. That's the growth of income from 1969 to 2010 in California. Then I want to also bring in the log of starting income, percent of the population with no high school education, and the population density in each county. And then I use the head command to give me just the first 6 rows of the data frame. And you can see how nice it prints out. It's really easy to inspect your data, make sure you got the right thing. Right, so this is a data frame. It's really an enhanced data frame because it actually has spatial information associated with it. Okay, so that's our starting point. I'll go a little bit quickly through this. I will show you that it's really easy to say, hey, I want to have a new data frame. And this one, I want to grab the same information, but I only want to pull out the row if the percentage of the population with no high school education is greater than or equal to 40%. Right, so I'll go ahead and do that. And now when I look at right, I have a different one, right? Well, as a matter of fact, I guess all those ones did have it, but let's see what the len is df2. Right, so instead of 58, I only have 33 rows. So you can do SQL queries on the fly. That's pretty nice as well. Okay, there are converters, SP and SF. We'll talk a little bit about SF. That's new, but SP is probably the longest lasting spatial object in there. And a lot of libraries require SP objects in order to do the analysis. So we have converters, and it's quite easy. You take your original data frame and you can convert it to this SP object. So now we have an SP object. An SP object has additional information, right? It has all your columns, has min-max values, it has its type is spatial polygons data frame. Okay, and I need that because I need to do analysis, and these, particularly this LM test and the lag model for the spatial autoregressive models require this. So I'm going to go ahead and run a regression, and I'm going to check my residuals to see which spatial model is most appropriate. And after running my regression, the lowest p-value for the lag statistic is for the Lagrange multiplier test is the robust LM lag. It says to use the lag model. So I'm going to go ahead and run it with the lag model. And again, don't worry if this is over your head regarding the actual analysis. It's not that big of a deal. What's really important is that the lag provides you with residuals. Those residuals are how far you deviated from the best fit line, if you will. And so I want to then take those residuals, add it to my original DF. So all I'm doing, look at how easy it is to add a column to my original data frame. I'm just going to assign the residuals to the same original DF. So now, when I check head DF, now I have a new column called resid. That's the one I just made. So it's really simple to add the column. Once you have what you want in the set of columns, then it's a one-liner to get the data back out to ArcGIS. So that's just written that feature class back to ArcGIS. So a couple lines of data to get a couple lines of code to get the data in. Then you use your expertise, use the CRAN packages, you use what you use to make you special, what's important about you. You do that analytic, and then you use a couple lines of code to get the data back out, right? Very simple stuff, right? Which is nice. So you don't have to worry about the data I/O, you just worry about what you do. Okay. Now, originally we didn't have any raster support, but we were harangued constantly for it. We need raster support. And we listened. It took us a little while to do it right, but we got it in. So there are a couple of things new to ArcGIS binding package, but the ability to read and write raster data was the most important. It's compatible with CRF formats, uses mosaic data sets. You can chunk by bands, chunk by rows and columns. So that's pretty fantastic. So you don't have to load these giant rasters all into memory at once. If you know how to chunk things and do analytics on the fly like that, then you can do that. So yeah, it's able to customize the selections, do extent selections, do subsets of the data. You can also use resampling for your pixels. So there's lots of different things that you can do with the rasters. And we'll take a look at that in depth in the next demo. So another thing that's new in the ArcGIS binding package is the SF package. That's Edzer's new package. That's a different replacement, if you will, or an updated SP object. And this is gaining some traction. People really like it. So the SF package has more than just the points, lines, polygons. They have like gridded information and things like that, cube, space-time cube type things. So the SF package, you may want to take a look at it because it looks like it's gaining momentum moving forward. We've also added the ability to delete objects that you created that were written in ArcGIS and R. So you can do that within R now. Let's see. So how do we do it? It's the very same thing that we did with the vector data. You always start with this describe or this open. It's setting up a link to the data that you want. And again, it gives you a description of the raster that you're interested in. And then, just like the other one was select, you use arc.raster. Now, arc.raster is going to take that info as the first argument, but you can say, I want how many rows, how many columns out of it, which bands that you want. You can clip based on a certain extent. You can say which pixel type you want. And if you are giving rows and columns that are different than the actual inherent raster is, then you can give the resample type, right? Because it's going to have to resample if the granularity isn't the same as the original data, right? You can also project these things on the fly. So how do we do? We convert ArcGIS data to the desired R object. And so now we can take our ArcGIS data and make all of these different data types, not just the vector data. Now, just like the SP object and the SF object are main libraries inside R to do spatial operations, the raster package is the core way to use rasters in R. It's sort of industry standard. There are others, but raster is the sort of leading one, right? So we have a converter to that raster object, and it's just as.raster. So when you as.raster, you pass in our raster, our arc.raster call, and it's going to convert it to that object for analytics. So let's take a look at how that looks. Now this one, I'm going to do a little bit less about the analytics. It's going to be more about what operations you can do with the raster. So again, same calls here. I'm going to go ahead and library source the raster. So I'm going to open the raster just like last time, call it info. Let's take a look at info. Just like last time, it's like a describe. It gives you a lot of different information about it. I have 64 rows, so I use a very coarse raster because I wanted to show you the chunking. It's a lot easier to use it with a small raster. You would probably have thousands upon thousands by thousands, right? But regardless, I used a very small one. But there's a lot of information. There's your prog string. It's what format it is. Okay, and just like last time, I'm going to use instead of ArcSelect for a vector, I'm using arc.raster. And then immediately I'm going to just do as raster. So now this is like making an SP object. So now I have rast. Both the ArcRaster and the rast have a dimension function to tell you what dimensions there are. Some people like to do their math. They can hold it in memory and they want to do linear algebra and things, and they just actually want to treat it like a matrix. So you can take that raster and just treat it like a regular R matrix, that matrix type. So you can convert it if you want the raw data, you can do that. More importantly, I can import a coarser set of rows and columns and change the projection. So I give it a new proj ID, and then I say instead of 32 by 64, I want 10 by 20. And it's going to use the default resampling method when I do that, but I can see that it's 10 by 20 with one band. Okay, so it's real simple to resample. Now I can also clip based on an extent. So this is me, go ahead and read the same information. I can take a look at how many null values are in that. 128 null values if I read in the extent. So essentially it's going to have the same number of rows and columns, but if it's outside the extent, you end up getting null values. I can resample on the fly, and this time I'm going to use cubic convolution for my resample type. Now, how do we use pixel blocks? There's two ways to do it. You can use the raster function, which I'll show you last, or like me, I like to do things in 1D indices. So I wrote a little method that will go through and you give it the start and end, and essentially it's going to give you the eye through if the matrix itself was flattened. So I just wrote a little method to do that. And I'm going to start at my flat index of 2561, and I'm going to go through and grab some information from that. So that's the information when I want to read just a pixel block using flat IDs. But generally speaking, people don't want to do it that way. They want to use the function, and I get that. That makes perfect sense to me. So the easier way to do it is to just use the pixel block function. This information up front will tell you what X to start at, what Y to start at, and then how many rows and columns to read. Very simple, right? So I want to start at this index 1010, and I want to read 5 rows and 5 columns from that starting point. So you can see I wanted 5 by 5, I get 25 values. So that's how you would do it if you had a giant raster and you didn't want to soak up all the memory. You'd use these pixel blocks. You'd probably write a loop and you'd go through and grab block by block, do analytics, pack the result in, and move forward. What's really important to note is that I use cubic convolution to resample. You would do something far more, difficult, but you'd have a new raster, right? Based on whatever, raster math, what have you. And you want to put it back into ArcGIS. Well, just like the last one, arc.write's going to work. So I have some new raster. I want to write it to this finer grid function. It's actually going to a GDB instead of a TIFF. And I tell it I want to be able to overwrite the info if it's already there, and I run it, and then that goes ahead and it writes the information back to a geodatabase. If you want to then write a script tool, there's a really simple function on the Vignette. You'll see a lot of examples in the doc that we have. It's real simple. You just pack it in a tool exec function with in params and out params, and then wrap that around the code you already have, and it's going to go ahead and run as a script tool. So when you create a Python script tool, you say, I want a new script. You do the parameters the same way you use a Python script tool, but then you source a .r file instead of a Python file. Okay, and we are, let's see, we are ready for you. You want to switch the...
Can you hear me in the back okay? Yeah. So Marco introduced some of the core capabilities and what is new in ArcBridge. And I want to show another dimension of our integration in addition to capability, being able to work with different types of R. And I will define what those are, why you need them, why it is important. How many of you heard about MRO? Just a raise of hands. Microsoft Open? Great. So there was one hand in the back, so that's actually one more than last year. So we are gaining traction slowly but surely.
What about Revolution? Has anyone heard of Revolution? No?
Okay, we haven't gained traction in that dimension yet. It was 0 last year as well. Slowly but surely. So you know how to write R code. How many of you feel like you're running into performance bottlenecks when you're in your kind of like day-to-day data volumes, that it's taking a little bit longer than you like it to? So this may not be a problem now, but this can be a problem quite soon in natural sciences, city planning in general. So I'm going to talk about Microsoft R, and this is Microsoft projection. So we are producing a lot of data. So by the year 2020, they are thinking that about 50 gigs per day, that's going to be pretty regular in terms of data volume that we need to deal with. And we want to make sure that R can deal with that going forward. We want R to scale. We want it to be fast because we have, as Marco mentioned, we have a lot of very powerful libraries in R that we may not want to reinvent the wheel. So we just want this to scale very well. And in sciences as well, we want to make sure that we can go through massive amounts of data. Especially with the raster integration, a lot of us work with very fine scale rasters. This brings challenges in terms of linear algebra that you need to do, in terms of the data you need to hold in the volume. This is a big challenge. So the little monkey you're looking at is the R symbol for Microsoft's version of R. So why is there another version of R? What did Microsoft really do? How is this different? Actually, let me first start with what it is not, and this is a common misconception. So do you need to now learn a different way to write R code? Do you need to learn a different language? No, definitely not. The R code just stays the same. What Microsoft did basically is they took a lot of the C++ and C backend that the R code calls out to. Like Marco mentioned, if you're talking about these performant libraries, they probably have a C++ backend to them. They replaced it with their own enterprise MKL library that is highly optimized. So the code that you're looking at is exactly the same. In the backend, it's just much faster because Microsoft implemented their own C++ library in the backend. So you don't really see anything as the R user. So, and also they bring different flavors of R, and I'll talk about what those are in a minute. So from our perspective, we can also bind into Microsoft's version of R, and today I'm going to talk about what is the advantage of doing that and why you want to do that. The integration is exactly the same, and I will actually show you how to use the ArcGIS binding on Microsoft R and how to bind it. That's step 0. And if you come to our workshop in the afternoon, and I'm also told that it's, maybe I should refer to it as a seminar. It's free of charge, so it's not a workshop, as in like a paid workshop. So all of you are welcome to come. It's at 1 today. But I'm just going to show you a little bit about how to bind ArcGIS into Microsoft R. So I talked about these different flavors of R. So what do they mean? At the core, you see cron. This is the version of R we use, open source, that we know and like. There is Microsoft R Open that has all the functionality, all the libraries in cron, It's just more efficient, especially with matrix operations, linear algebra. This is really fast. You might be thinking, well, I don't really do a lot of matrix multiplications. Well, any function that you use probably is at some point doing a vector algebra somewhere. It's probably multiplying two vectors, doing a solution somewhere. So this gives you a performance boost. Then they have another type of Microsoft called Microsoft R Client. So this allows you to actually write parallelized code. And now they are coming up with a GPU version of R as well, so you can potentially parallelize your R code on a GPU, which will make it much more performant. You can get thousands and thousands of times a speed up just with this GPU implementation of R. And there is the Microsoft R server. So all of us in R, we love R for a reason. It's our community, it's open source, we all contribute to it. And this is a little scary, a big company kind of having their grip on that is free and something that we love. So the dome of open and free kind of ends at Microsoft R Client. Everything up to Microsoft R Client is free for you to download and use, just like R. Microsoft R servers is if you have a giant organization, if you want to do multi-threading, if you want to run this thing on a cloud, build apps with it, then Microsoft R Server becomes handy. Today I will show you how to use Microsoft R Client and R Server and kind of what it does, just to give you an idea about it. And I will, in my demo, show you how to use our mosaic functions too. Since we support these new data types, it actually became very apparent as we were preparing material that when we have this extra dimension of time, our data got big really fast, even with this new raster functionality. And now the R-ArcGIS bridge also reads time series mosaics and spatial mosaics. So we saw that the data is getting really big. So I'll show you an example of that. And the mosaics is, the mosaic data set is pretty much the same, so I'm not going to dwell too much on it because Marco already talked about this. And I will actually do my demo on yet another new thing that now you're going to have with Pro 2.3. These are the R Jupyter notebooks. How many of you use Jupyter notebooks? Great. So now you have the option of doing this with Jupyter notebooks as well. So the mosaic example I'm going to show you today, and this looks exactly like a Python Jupyter notebook. So here I have a mosaic data set. This contains a spatial mosaic that has overlapping rasters. I can use the same ArcRaster functionality to read this data set. The only thing that is different with mosaics is the method. In order to be able to resolve different spatial overlaps, you need to define what comes first, what's going to take precedence when you're merging this mosaic data set into one raster. And this is the method. This is the same terminology we use in ArcGIS Pro. All the same methods and reduction operators we have, you can define it in ArcRaster. And the resulting raster looks something like this. I have, as you can see, I have 5 distinct patches over United States. This is temperature profile. I can just do a bad job, in this case, of just melding these together. If I want to do a better job, I can process this on the fly and use the seamline method to average over where these rasters overlap and bring in this mosaic as a more clean raster. So here, the main functionality is using the ArcRaster object. You can actually process a mosaic on the fly and create a resulting raster without doing any intermediary operations. So all the heavy lifting going from mosaics to rasters is done for you within the ArcRaster object. So this is one of the main value. And we do not have a separate function for mosaics. You can use ArcRaster for rasters and mosaics. And for those of you who are working with a wide variety of mosaic data sets, this is very powerful. And you can describe a mosaic. One thing that is really cool is you can also upscale or downscale a mosaic. For example, I'm changing my resolution, again, on the fly, using the averaging method I defined, using the blend. I can just create a coarser raster If you just want to visualize what your mosaic will look like without burning through your graphic card, you can just simply do this, and everything is done on the fly, and it's highly efficient. So I did this notebook using Microsoft R, and one question that always comes up is, how do I set it up? So it sounds a little promising, but this sounds like something different. Well, if you're using Pro, I'll go to the project ribbon, go to Options, Geoprocessing. So the R-ArcGIS support ribbon is now detecting all the installations of R I have. And as you will see in a minute, I do have a serious R problem. I'm overusing R. I have many Rs installed on my machine. That's why it's taking forever. But it's going to detect all the R versions I have on my machine. And for every R that is installed on this machine, so I have Cron's R, R3.5. I have Microsoft Open, 2 different versions, and I have the ArtServer. For example, if I want to install the R bridge on the ArtServer, I just click on this version of R. It's going to check if R is installed. In my case, it is, but if it wasn't, here this tab was going to say, install R-Bridge from the internet, and you click it, and that's it. You have R-Bridge installed for that particular version of R. So the question is, oh, hey, I'm interested in Microsoft Open. I had already this version of R, now I installed Microsoft Open. Do I need to do separately for Microsoft Open as well? Do I have to set the bridge for that R version? And the answer is yes. But you do this only once. Once the bridge is set for this version of R, you always have it, and you always can use it. So this is very simple to handle. So what are some of the speedups we're talking about? I wanted to make a demo out of it, but then I thought you may not want to wait here for 25 minutes to watch something spin and do this experiment. So I did this experiment at home. What I did is I took 2 rasters and I run a convolution operator. What you see in the x-axis is the size of the raster. So I took a 100 by 100 matrix and I run a convolution operator on it. You can think of this as like a simple matrix multiplication. The green line is how much cron took, and the orange line is how long Microsoft R took. So if you have a raster that is 10,000 by 10,000, processing this raster is about 5,000 times faster with Microsoft R. So it does give you it can give you a huge speed up. And you do not run into many of the memory bottlenecks that you generally run into with Cron's version of R. So if you feel like your data is getting bigger, if you feel like the bottleneck is becoming a reality for you in your R workflow, Microsoft R is basically something that you can try, switch to. As I said, it's for free, and Microsoft promises that it always will be. The only catch to Microsoft R is if you need a library that came out yesterday, you're not going to have it for 6 months. Since they re-implement whatever is current in Cron, they have a 6-month lag. They take whatever just came out in 3.5.1, for example, and they release that version 6 months later because they are re-implementing things in the backend. So this is the only catch to Microsoft.
Oren, did you use Microsoft R Open for this test, or was it client?
This was Microsoft R Open. So there is no parallelization, no multi-threading, nothing. So this is just a regular console R that I use. So there is no parallelization either. That's actually a great point. So this is purely based on the underlying C++ implementation of Microsoft that's giving you this boost. So if you have big data, if you want to be 50,000 times faster, just download Microsoft R. And let me quickly show you the website. Microsoft R. It's called Microsoft R Open, or MRO. You just download it, and this becomes your distribution of R instead of cron. You can always switch back to R. The code is always portable. You don't have to do anything special. So this is the Microsoft story that makes things very fast and very efficient. And I want to talk briefly about ArtServer. So a lot of us consider consider R as a great place to prototype, to share our ideas, to share our new methods, ingest new methods with minimal effort. If you want to really scale this up without doing any extra implementation, you can use the ArtServer, and this makes things blazing fast. Microsoft actually gives Azure machines for you to use, and if there are some of you in academia doing that, you can also get Esri grants to use these machines as a part of the Esri scholarship. So this just scales things up pretty dramatically. And if you're wondering how dramatically, I'm going to take you through a very simple example using the ArtServer and just show you the speed up and some of the code I need to write in the backend to do this speed up. And I will do this for the remainder of 5-10 minutes or so. Okay, so this is my Azure machine. What I did here is...
Can you make it bigger?
Sure. I think the easiest way would be to do this.
Yeah, good.
So what I did here is I spun up an ArtServer. And again, if you come to our session in the afternoon, I can talk about how you'll be able to do this. This takes a little bit of time, but after you set up a web node for R, so this is basically just creating an R ecosystem. And when you have ArtServer, it actually does that for you. It tells you, hey, what do you want to do? Do you want to create a couple of web nodes? If you say yes, it asks you how many. So it has this interactive command line that you can do. So whenever people hear ArtServer, there's always some panic because in R, if our main language is R, we generally do not work a ton with parallelization or with cloud implementation. So what does this mysterious ArtServer looks like? Is the code too small? Can everybody see the code in the back? Kind of. I will just do this. Maybe one more.
Control plus. No?
This is yeah, let's get in there. Better? Yeah, good. So the R code looks exactly the same. And today's example, I have this raster of Southern California. And how many of you work with rasters? Not necessarily all the time, but every now and then you have raster data sets that you need to deal with. Great. So I'm going to calculate this thing called an NIR index. NIR index is very simple algebra on a multi-band raster. So this is the function I'm going to calculate. I'm going to take the red band of this raster and the NIR band of this raster. I'm just going to subtract two rasters and divide it with the addition of these two rasters. That's pretty much it. So I'm going to subtract two bands, divide it with the addition of two bands. This is the core function I'm going to do. This is what I need to calculate. Well, this is simple enough. What happens if you just give it to R? This raster has slightly more than 200 million pixels. So it takes quite a while when you do this in R. For one, you have to hold the entire matrix in memory. But Marco showed you how to do chunking, so you can chunk small portions of it. Even with that, this takes a while if you put in a for loop. So I integrated RBridge into ArtServer. Again, I did the exact same thing. I just went to Options, Geoprocessing, and I pointed to ArtServer, so my bridge was set up. And now I'm running ArtServer. And for those of you who like using RStudio, you can always go to Tools. After you install ArtServer, you can just point to our version to be ArtServer. So this really is the only difference. It just runs the server implementation in the background for you. Okay, so let me get to the fun part. What did I really do here? Okay, so as I said, I had this function. I used ArcOpen to read my TIFF, my raster. I use ArcRaster to bring in the data. So I have this pointer to data. And I defined a very simple function. We talked about that. So this is where ArtServer starts. ArtServer first has this function called remote login that logs you into the server you created. And after you log into the server, one thing you can do is you can define services. You can define APIs. In this case, the API I defined is basically a web service that does this operation. Whenever it receives a raster, it subtracts the 2 bands and divides it with the addition of 2 bands. That's what the web node does. So in the first example, I did it the R way. I read the whole data in, and I just calculated this operator. That's really the only thing I've done. I have done no tricks. I did not do anything else. In the other one, I used chunking. But I used chunking a slightly different way. So what I did here is, when I went to this raster, and here is the raster I read in ArtServer, the same raster I had in ArcGIS Pro. Whenever I read in a window, I sent that window to one web node. And when I read another window, I sent it to another node. And I had thousands of nodes simultaneously doing operations. So you can see that this is going to be much faster, right? Because I'm not waiting on one processor to finish the job. I'm actually sending small chunks of rasters to my web nodes to do this operation simultaneously. And I publish this as a service. And publish service does exactly that. But the R-ArcGIS bridge comes in the chunking portion that I will show you very soon. So you can define APIs like this. And what I did here is I first sent the entire raster to one web node that basically had enough compute power of my entire machine. So let's see how long it took. And here is the full matrix solution when I ran this code. It took 80 seconds. So this was actually pretty powerful. For this many raster cells, it is really fast. And then I did chunking. What I did is I basically chunked it, and I sent small portions of my data to my 2 different web nodes. That's really all I've done. And I recorded how long this takes. So 80 seconds when I did it the regular way. When I use ArtServer to send the job to different nodes, it takes 0.27 seconds. If you really want a number for a speed up, I used R's powerful division operator. To calculate that, it's about 300 times faster. And really all I did was just define a couple of web nodes and send my job to it. So when you're waiting for 80 seconds, that's not too bad. When you're waiting for 80 days, now that's a problem. Or when you're waiting for a week to process a raster just to figure out that one of the parameters was wrong and you have to do it again, now that's a problem. So this way, you can actually make it really fast, scale it up, and you can even publish these. So how do you publish these? So for those of you who are not familiar with server terminology, what APIs are, that's not really important. As I said, I created this function, and this function lives in web nodes. And it does something very specific. It only knows how to do this function. There is a system called Swagger in the R ecosystem. It creates this thing called a Swagger file. It's a JSON file. And this really lives on my hard drive. It lives somewhere on my hard drive. Yes. It's a JSON file. So what does this really mean? Well, if I'm a provider or if I'm a fellow scientist, if you said, oh, hey, I had this giant raster and I really like your NDVI function, can you help me out? I can really just email you this JSON file, and you can port it on your cloud and use the exact same architecture I use, the exact same function I use. So you don't really have to write any code. All you do is import this JSON file. You have access to the architecture I used. So if you have ArtServer as well, you don't have to know anything about server. And this is portability. This is being able to share your work and scale your work. It's very easy. This is called a Swagger file that has a JSON description of what I've done. So this is one of the advantages of ArtServer. We are hoping to have a tighter integration and a much more user-friendly, hopefully a pro-centric story around ArtServer as well in the future. But now this is kind of like a prototype that I've been playing around with this year, and basically not doing anything else but just chunking my raster and sending it to different web nodes. I get 300 times speed up. And I haven't even done any optimization on the function itself. So yeah, this is basically it. You can scale your work, but if you do not want to deal with this, I highly recommend for you to just take a look at Microsoft Open, because it'll just make things much faster for you without any of this. Just a regular R console that is just much faster and performant. And I would like to finish with some of our resources. For those of you who were here last year, you have seen almost all of this, but the one on the top, now we have R-Bridge tutorial notebooks. The Jupyter notebooks I showed you, we actually created a couple of examples for you to get started with. So that's in GitHub. I'll give you some time to type it, write it, or take a picture. So no rush. So this is very useful. You can really see the patterns that we used. Because it's good to have the library, it's good to have a vignette and documentation. But there are many ways to do something right, and there are many ways to do something wrong. So we posted some patterns of what we think the right ways are to help you guys out. So you can see our Jupyter notebooks in here. And yeah, please take our survey and tell us how we can improve this thing. Thank you.
Do we have questions?
What's the cost to use ArtServer, or is that one free too?
What's the cost for ArtServer?
So if you get ArtServer through Azure, they pre-configure it for you. So you basically pay Azure credits. So that's flat Azure, the Azure machine's rate that you have to pay. If you have someone who knows how to set up servers, they can also download ArtServer and set it up themselves, in which case it's just going to be your own server cost. Yeah. This really is just a server implementation of R.
Any other questions?
Yep.
Maybe I'll just yell out.
Okay.
So for all of the Operations supports both 64 and 32-bit versions?
Yes. We do support both. The question was, do we support 64 and 32-bit R versions? Yes, we do. And we also have compatibility with desktop as well.
Well, for some clarity, when you're on desktop, when you're on ArcMap, you're essentially most of the time going to be using 32-bit. When you're on Pro, it will be 64-bit.
In general, do you find the same increased efficiency with dealing with vector data as well as like illustrating with raster data?
Yes, we do. Right, because at the end of the day, even our rasters are just flattened into vectors whenever we do any operations on them. At the end of the day, we cannot escape doing a vector multiplication or a vector operation somewhere, right? This can be something ecological like maxent, or this can be like a network operator. So yeah, we still get the speed up no matter what the type of your data is. We just use a raster example because it's moving from rasters to mosaic, something multi-dimensional. The increase in data size is actually pretty visual as well.
In my example in particular, the lag model, that's all linear algebra in there, and some pretty high-tech linear algebra maximum likelihood solutions, and you're going to get tons of speed up just using Microsoft OpenR for that.
Any other questions?
Can you show the previous slide again?
Oh yeah, of course. And yeah, if you want to get set up and do some workflows with us, please come visit us at 1 p.m. today. We have the hands-on workshop.
That's next door?
It's next, I don't think it's next door. They need to look at the schedule. It's going to be on the schedule. You can find it on the schedule. This is a 5-hour workshop. All you need is just, if you have Pro, that's great. If you don't have R, we'll have to get set up. And yeah, that's really all you need, and some enthusiasm.
And there'll be lots of us there helping, not just 2 of us. So it'll be a real workshop, and there'll be about 4 people walking around helping people. So if you got your computer, you want to learn how to do this, get hands-on, you can do it today, get started today at 1 in a room that we still don't know. You don't have your schedule?
I don't know the room. I can look it up.
Any other questions? Well, thanks so much for attending. We really appreciate it. Have a rest of your time.